Hello and welcome to another day of Scientific Week. And for today's topic, I am going to discuss and show to you the heat transfer, basically conduction and convection. We will have an experiment on how does these two heat transfer works. For conduction, you need an iron, wire, stone, candle, screw, or nails. Here are the materials. So first, let's make the stand. Tie the wire around the rock and it should look like this. Next is pick up your iron. Tie your wire around the iron. Use the candle wax as your base to hold the screw in place. Drop a lot of wax to hold the screw stronger. It should look like this. So first, conduction is how heat travels through touching. As we put more heat on the iron, these three screws will fall. To start, first, light up your candle and place it on the tip of the iron. I will leave it here and set the time for about 10 minutes. In 1 minute and 21 seconds, the first screw falls. I tried to touch the iron, but it is not hot enough to melt the wax on the second screw. The heat travels slowly because of the thickness of the iron. For the second time, I tried to touch it, but it is not hot enough. In 4 minutes and 12 seconds, the second iron falls. Because heat travels very slowly, the heat did not reach the third screw. So that was how conduction works. For convection, we need a cup of water at a normal temperature, food coloring blue and red, and a cup of hot and cold water. First, mix the blue food coloring to the cold water and red for the hot water. To start, pour first the cold water. As you can see, the cold water settles at the bottom. And now I am going to add the hot water. As you can see, hot fluids rise up while cold fluids sinks down. This up and down motion is called a convection current. Convection current spreads the heat in a circular up and down pattern. Example of this is when you boil water. As the warmer part rises, it loses its energy and sinks, while the colder part gains energy and rises. This continuous cycle of losing and gaining energy by molecules in a fluid leads to the formation of convection currents.